Trapezoidal rule or trapezoidal integration, quote unquote. All right, some functions are so difficult to integrate that we approximate them using trapezoids, just like we did with rectangles. So does anybody know what a trapezoid is? They look like this. This is a trapezoid. Like it has two different, that's kind of a trapezoid, right? You have two different lengths essentially, or what we're going to call bases. Now, if you turn that vertically, we can stack them under a graph. And you can see you can get a better approximation because of the slant than just a regular rectangle. Okay. Now, the formula for a trapezoid is the area for a trapezoid is oh, now I forget. What am I going to write? It's the width, so x b1 plus b2 over 2. You can look that up. So essentially, it's like we've turned the trapezoids on our sides. So the x is the width, and the heights are, I'm going to call them h's instead of b's in the formula. h1, and then this would be h2 to different sides, okay? And if you add up all the trapezoids, you can approximate the area, all right? So if you're going to write it out, we can say the integral of f of x dx between a and b is going to be the sum of the trapezoids, which is going to be delta x, because that's going to be the width of each trapezoid. I'll show you a formula for delta x here in a sec. Well, it's the same as the other one. Times, I'm going to call it h1 plus h2 over 2. So this is the width of the trapezoid, and this is the, for lack of a better term, the height. Although you're kind of averaging the heights, as you can see. Okay, now that looks gross, so we're going to clean this up. The width is the same as it was for the rectangles. It's this value minus this value divided by the number of trapezoids, which we're calling n. So delta x is going to be b minus a over n, where n is the number of trapezoids. I'm going to call them traps because I'm too lazy to write the whole word. And then if you notice, if you look here, like look at this one right here. That's h1, this is h2, and then this height. So the outer heights, the a's and b's, if you call them, they only get used once if you think about it, because this trapezoid here is going to be this height plus this height divided by 2. That's this bit of the formula, okay? And then the next trapezoid is this height plus this height divided by 2. And then this one is this height and this height. So you can see all the heights in the middle get used twice. Does that make sense? And the ones on the outside, these two, only ever get used once. Okay? All right. So we're going to say, I'm going to pull out the 2 because, and we're going to say the integral is going to be approximated by delta x over 2. And then it's going to be h1 plus h2. So instead of writing that, we're going to write, and no, we're not going to write the heights as h1, h2, because it's an actual function. It's going to be f of x0 plus 2 times f of x1 plus ... That's term 1. You'll see in a sec. I'll show you how to get those. Plus 2f of x to the n minus 1 plus f of x n. These are the heights in here. Now, it looks like a complex formula. It actually isn't. Once you do a couple of them, it makes perfect sense, okay? So that's the formula we're going to use. Now, so how do we solve these things? We're going to go approximate we'll do one that we already know, x squared. Okay. We could do that the other. I'm going to show you. We're going to do it both ways, and you'll see how close you can get to a decent number. We're going to use, so approximate this using 5 trapezoids. Okay, so delta x is b minus a over n. B minus a, 7 minus 2 over 2, which is 5 over 2. Whoa. N is 5. Why did I write 2? Nobody even yelled at me. Sorry. N is 5, because n's the number of trapezoids. Sorry, I don't know what I was even thinking. N is the number of trapezoids, okay? So it's going to be 1. So delta x is 1, okay? That means then you just have to do a little bit of thinking, okay? We're going from 2 to 5. If the width is 1, which is nice and easy. Oh, 2 to 7. Oh my gosh. Sorry. I feel like I'm skipping today. Okay. 2 to 7. If the width is 1, then it goes from 2 to 3, 3 to 4, 4 to 5, 5 to 6. The reason you need those is those are going to be your x1, x2 values that go in here. Okay? So we go, all right, we're going to approximate this. It's going to be approximately delta x over 2, so 1/2. And then you start on the left. F of x0 is 2. So f of 2 plus 2 times, what's the next x value? 3. And you just go all the way up. 2f of 4, 2f of 5, plus 2f of 6. And then on the last one, it's just f. It's not, doesn't have a 2 in front of it. Plus f of 7. Does that make sense? Okay. Those numbers literally go into your function. Our function is x squared. So we get 1/2 f of 2. So if I put 2 into x squared, I get 4 plus 2 times 3 squared is 9. 2 times 16. 2 times 25. 2 times 6. And then plus 49. And that is just algebra. Or not even algebra, just adding numbers together. Oh, if I put 6 in, I get 36, which is 72 and 49. Okay. And just add them up. $225. 112.5? Does everybody agree with that? Yep. Okay. So that's the approximation using 5 trapezoids. Let's see what the actual answer is and see how close we actually get. The actual answer, because we can do this using our integration properties, 2 to 7 of x squared dx, antiderivative, x cubed over x, between 2 and 7, 7 cubed over 3 minus 2 cubed, which is 8 over 3. Is that? Equals divided by 3 equals 111.6 repeating. So we're off by 1.9. All right, that's pretty good considering we only used 5 trapezoids. Okay, so even with a low number of trapezoids, you can get very close to the answer. Obviously, the more trapezoids you use, the better it's going to be. Okay. Yeah, you did like however many terms you're going to have, right? So, but 5 we get within 0.9 of the actual answer. That's pretty good. Okay, that's trapezoidal rule. The formula, I'll give you the formula. I'll give you this. All right, but you just have to know how to use it. The only part that people mess up on is they'll figure out delta x, but they mess up on getting the x values that go into this part. And then they always forget, or they mess up somehow punching that into your formula. Okay? I'll just give you practice ones from the book. We'll do page 3. That's it. The chapter's over now. Page 310. Numbers. We'll do 3, 5. What's 35? 35 and 35. Yeah. 35, 35. It's going to say Simpson's rule in there. Simpson's rule is another way to do it, except you use parabolas to approximate it. And it's more, you get a better answer, but we're not going to worry about Simpson's rule. On the test, I will ask you a trapezoidal rule question where you have to do it, and then I'll ask you to actually give me the actual answer using basic integration. All right. Monday, Tuesday, I will outline the test. I'm going to hand out the test last year from the Math 100 class. The key is in the classroom. I've posted all the reviews in the classroom. I think that's it. Monday is just review. You do those questions, you should be good. People that didn't show up next time. Bye.